Hello everyone. Here we are to do the self-assessment test in the P block element. So let us start with the assessment. So these are the questions related to 15 and 16 group elements. The first question is, which of the following does not shows donor property? Electron donor property means Lewis base property. As you have done in the hydrides, that which one is the Lewis base? Yes, that is the NH3 is the Lewis base. So we can say that PCl3 and NCl3 both will not shows the electron donor property. So the answer will be D. The answer for the first question is D. Now see the second question. That is complete the reaction. As you know that NH3 is a Lewis base and it is a good complexing agent. And the reaction with Cu plus 2, the 4 ammonia molecule will be react with the copper and you will get such kind of the reaction. So this kind of the complex you will get with the copper, and whenever you will do the same reaction with Ag, so 2 NH3 molecule will be react with it and there is a formation of such kind of the complex like this. So here you can complete the equation by writing this complex. Now the question number 3 is the assertion reasoning question that NCl3 get readily hydrolyzed while NF3 does not. Hydrolysis means that there the coordination number must be increased. Now you can say nitrogen does not has the vacant d orbital. So nitrogen cannot gain the lone pair of electrons for the hydrolysis from the water molecule. But the chlorine has the vacant d orbital to accept the lone pair of electron. So the coordination number can be increased and the water molecule can make the bonding with the chlorine and the hydrolysis is possible in case of NCl3. So we can write the answer is A for the question number 3. Now the question number 4 is ion which is isoelectronic with NO3 minus. As you know, isoelectronic species are the species which has the same number of electrons. So you can calculate the number of electrons in NO3 minus. That in NO3 N with 1 minus charge. So 1 electron can be added. So 7 electrons for the nitrogen and in O3 24 electrons because the 1 oxygen contain the 8 electrons and plus 1. So you can calculate the number of electrons comes out to be, and then you can find out the number of electrons present in them. So you will find that answer will be, in this case you can see the answer will be CO3 2 minus. You can easily see that carbon which contains 6 electrons, 6 plus 2, 8 electrons, 8 plus 3, so 7 plus 8, 8 plus 24, that is 32 electrons will be comes out. And both are isostructural also. इसका structure भी same होता है. Promoters used in Haber process. As you know, iron is used as a catalyst and the molybdenum is used as a promoter. So be careful about the catalyst and the promoter. So in this case, the answer will be C. Now the next question is, which shows high tendency of the catenation? In case of question number 6, now think about which one has the high tendency for the catenation in 16. These are the 16 group elements. So you have done that sulfur has the high tendency of the catenation. You can see these compounds of the sulfur जो आपको ने पढ़े भी हैं कि these kind of the compounds of sulfur will be formed because of high dissociation energy of SS bond. Now in the next question, question number 7, that which is more acidic in nature. Now you will see the hydrides series, that is 16 group element, that as you go down the group, the size will be increases of the central atom and the bond dissociation energy between the hydrogen and the element will be decreases. So that this will be the highest, more acidic in nature. Now in question number 8, see, it is a fill in the blank type question. Tendency to form p-pi multiple bond dash down the group in the 16 group element. So what will be that? P-pi multiple bond will be formed when the element will be small size and high electronegativity. So you can easily see that when you are moving down the group, size will be increases and the electronegativity decreases. So both the conditions will be not favorable for the p-pi multiple bond and the answer will comes out to be decreases. Now the next one is oxidation state of sulfur in H2SO5. As you know well, H2SO5 is the peroxo monosulfuric acid. So first of all, you have to be write down the structure for the peroxo monosulfuric acid, and the structure is like this, in which the one peroxide linkage is present. And in this peroxide linkage, it has -1, -1, -2 charge, -2 charge, and here it is -2 charge. Now you can easily find out what will be the oxidation state of the sulfur in H2SO5, and that is, you will find it comes out to be +6, because the changeable is only for the peroxide linkage, that one peroxide linkage is there. Now in question number 10, form of sulfur shows paramagnetic behavior. As the sulfur is present in the elemental state, it is present in S8 molecule. In S8 molecule, it is diamagnetic in nature. But whenever it is heated, it is converted into S2. Like O2, it has the 2 unpaired electrons in the vapor state. And because of that reason, S2 in the vapor state will have the paramagnetic behavior. Now the question number 11. In question number 11, we are having the 3 short questions which are belongs to the hydride of 16 group element, that is which has the lowest boiling point. So yes, you are very much right, that is H2S. Maximum thermal stability, that is H2O, because of high bond dissociation energy. Weakest acidic character, again the weakest acidic character is of H2O, because down the group the acidity of the hydrides will be increases. Now the last question of this assessment is question number 12, that is the what is the structure of SL2 will be. The structure of SL2 will be pyramidal, square planar, bent or linear. It is bent in shape. When you will see the structure of the SL2, it will be like this, which has the 2 lone pair of electrons like water. So we have covered here the assessment test 3 for the P block element. Now we will cover the one more assessment test for the 16 and 17 group element. So see the first question, that is, it is of type of assertion and reasoning type question. SF6 is known, but SH6 is not known. In SF6 and SH6, it is known and it is not known. Yes, this statement is true. Now, we will see the reason for this assertion. Hydrogen is small in size than fluorine. Yes, it is true that hydrogen is small in size than fluorine, but this reason will not justify the assertion. So, the answer will comes out to be B. Answer is B for this question. That is, the assertion and reason both are correct, but R is not the correct justification for A. And what will be the real reason? What will be the reason? Fluorine is more electronegative than hydrogen. Then we can say that it is the justified reason and the answer will become A. But here the answer will be B. SO3 has zero dipole moment. Why it is so? If it is true, why it is so? That SO3 has zero dipole moment. So you draw the structure for SO3 first. The SO3 has this kind of the structure, trigonal planar. Now you can see bond movement will be in this manner, subtractive. So it has the zero dipole moment because of this structure. Number 3 question. Dash will act as an oxidizing agent as well as reducing agent. That you have done in the 16 group element, that you can see all the sulfur compounds are there, species are there. Sulfur in +2 oxidation state will behave like an reducing agent only. In sulfur in +4 oxidation state will behave reducing as well as oxidizing, but sulfur in +6 will always behave the oxidizing behavior. So in all these cases, you have to find out the oxidation state of sulfur. And the oxidation state of sulfur comes out to be +4 in case of SO2. So we can say that SO2 is act as an oxidizing as well as the reducing agent. Now the next question is, which is used as a gas electrical insulator? Gas electrical insulator means which is inert, which is unreactive, which cannot be hydrolyzed. So all these cases you can say that BSF6, it is the electrical insulator because it is inert and because of sterical hindrance. When we will see the structure of SF6, structure of SF6 is like this, in which the sulfur atom is sterically hindered with the 6 fluorine atom, and the compound will not be find any site to attack on it. So it will be act as a electrical insulator. Next is dash has greater bond angle. Now in greater bond angle, you will find out that these are the hydrides of the 16th group element, and down the group, the electronegativity decreases of the central atom, and because of that reason, bond pair repulsion decreases. So H2O has the greatest bond angle among all these hydrides. Now in question number 6, dash is used for purifying air crowded place. Which one is used as a purifying air? So you will see SO2, SO3, O3 or N2. Now the answer for this question is O3. Why it is so? Because O3 will be unstable. It is thermodynamically unstable and it is a thermodynamic compound, endothermic compound, because the 2O3 that will be easily converted into 3O2. So because the end product is O2 for the decomposition, so it is act as a purifying air crowded places. As the formation of O3, जब हम O3 बनाते हैं, you can easily find out, जो हम कर भी चुके हैं, कि it is an endothermic reaction. Delta H is positive, delta S is negative, and the delta G comes out to be positive. That means O3 is unstable. All these conditions will say that O3 is unstable. So it is used as an air purifier. In question number 7, dash has more negative electron gain enthalpy. You know well that fluorine is more electronegative in nature. So you may think about कि fluorine, bromine, iodine or chlorine. So the answer जो आपको मिलेगा, that will be chlorine. But you will be get confused कि why not fluorine? Because fluorine is more electronegative in nature. It is because of the reason small size of the fluorine will causes the interelectronic repulsion, and because of that reason it has the less negative electron gain enthalpy than chlorine. So the next question is, which one is the strongest oxidizing agent? The strongest oxidizing agent which will be in which they have the strongest F2. It is because of the reason that F2 has the high hydration enthalpy and it has the low bond dissociation energy. And because of these two reasons, F2 is the strong oxidizing agent. Now in question number 9, degree of ionic character decreases in the order. Degree of ionic character. So degree of ionic character may, you have to be think about the Fezan's rule. In Fezan's rule, you will see smaller the size of the cation, more will be the covalent character. And the reverse is true for the anion. Means the smaller the size of the anion will leads to ionic character. So here you can see that cation that is H positive is same in all the cases. So we have to look after for the F negative, Cl minus, Br minus and the I minus. Now here you can easily see that fluorine has the F minus has the small size, and the small size of the anion will lead through the ionic character. So C will be the answer for the question number 9. Now come to the question number 10, where which has low bond dissociation energy. So it is very simple for you people. That is Hi will have the low bond dissociation enthalpy because of the large size of the iodine. It can liberate the H positive easily. Now in question number 11, dash will forms the hydrogen bond. Again, it is a very simple question. That is HF will forms the hydrogen bond because of high electronegative character of fluorine. Now in question number 12, increasing order of oxo acids regarding the acidic strength. Which one is more acidic in nature? Now among these three, this option is very much right, because in case of HClO4, the oxygen atom O negative will be dispersed among the 4 oxygen atom and make it more acidic in nature. So the self-assessment test has been completed over here, and in the next topic we will discuss about the more self-assessment test regarding the P block element. Before that, you have to write the questions in your copies and try to find out the problems.